Hello and welcome back. My name is Matthew. I'm the C# artisan, and this is the 6th video in my series on Azure Service Bus. And in this one, we're going to take a look at some alternative resolutions for a message. In the last video, we looked at how you can complete a message. In this one, we're going to look at abandoning and dead lettering messages. So here we are in the Azure portal looking at my test queue. And as you can see, I've got an active message all ready to receive. And this is our C# receiver code from the last video. And here on line 24, you can see that so far we've been completing messages when we're done. Well, what are the other options? So if I just use the IntelliSense here, we can see another option is abandon, dead letter, or defer. Now in this video, we're going to go over abandon and dead letter. Message deferral is a kind of slightly more complex topic that maybe we'll look at in a future video. So what does abandon message mean? And we need to wait for this to complete. So you might think that abandon means, okay, just get rid of it and we'll never see it again, kind of like delete it. But that is not what is going to happen. When you abandon a message, you're essentially telling the Azure Service Bus queue, I have no intention of ever completing it. So put it back in the queue. So you're going to see the message is actually going to go back into the queue. So we can run our test code here. And we wrote out the message one right there. That's the body. And now let's just go ahead and abandon this message, and we'll do F5 to complete it, or to finish the program, not to complete the queue. And then if I go back here and refresh, you'll see the message is still there, still active. So that's what abandon does. Again, it doesn't mean delete it. It means I am not going to decide its fate. I'm abandoning it. Someone else can have it. So it goes back into the queue. Now, one thing to be aware of, and we talked about this with our queue settings before, is you have this max delivery count. And every time we hit the timeout before and it went back into the queue, that counted against the max delivery count. Well, abandoning a message also counts against the max delivery count. So in this case, if we were to abandon the message 3 times in a row, then it would go to the dead letter queue. So I guess we could do that. I guess I can demonstrate that. So let's see. What we need to do is go back to Visual Studio. So let's just do this again. And we'll abandon it. And we'll run it. And abandon it. Now we've abandoned it 3 times. And if I go back to the portal and refresh, you'll see it went to the dead letter queue here. So now I need a new message for us to continue the conversation. So I am going to bring up my little magic message sender, and we'll put another message in the queue. So what is the next option? Hopefully that's clear on abandon. So now we're going to test out receiver.deadletterMessage async. This one is very simple. As you can imagine, it's simply going to put it straight away in the dead letter queue. So here is, let's refresh this. Here's our queue with an active message and a dead letter message. And we will go ahead and go back to Visual Studio and let's run this. So we received it and we dead lettered it. And if we go back to the portal and refresh, there you have 2 messages in the dead letter queue. So those are your 2 options. You can complete it, which means it just goes away. You can abandon it. It goes back into the queue at least a certain number of times. And you can dead letter it, where it will immediately go to the dead letter queue. So I guess this raises the question, well, why would you use these? What are the real world scenarios where this might come into play? So let me kind of write a little bit of pseudocode to tell you just one way to think about this. So let's say you've received a message, and obviously this is an application, and with the message, you're going to need to do some processing. You're going to be creating records or calling APIs or doing whatever you're doing. To use the metaphor we used before, it's in the kitchen and you need to cook some food here. So one way to think about this is you can do something like this. And actually, let's catch an actual exception. So in the try, we're going to process the message, i.e. cook the food, right? We're going to prepare whatever that means. Metaphorically, we have to prepare the food. Now, let's say something goes wrong in the preparation. You burn the parota, or it turns out that you're all out of pomfret, so you can't actually make the order. So what do you do at that point? So this is going to fall into your exception handler, and you're going to need to make a decision. And you're going to ask this question: is this particular message recoverable? I.e., what do I mean by that? Like, i.e., if we try again, will it succeed? So let's take the example I just gave you about preparing the food. So let's say you rolled out the parota and you put it on the griddle and you burned it. Well, you can try again, right? You just toss that one in the trash, and you can roll out another ball of dough and cook some more and get it right the second time. So I'm going to put in here, like, if retry might succeed, right? So this is some Boolean. So bool retry might succeed, and let's just say this is true for this example. So again, we're talking metaphors here. I don't know your application. You have to decide, what does that mean? So if retry might succeed, then what you want to do is receiver.abandon message, because it's going to go back into the processing queue, and then you can cook it again and not burn the parota on your second time. What is the else condition here? This is the situation where this message is just corrupt, or it's a request you can't fulfill, and you never will be. No matter how many times you retry it, you just are not going to be able to fulfill it. So in my metaphor, let's say the customer ordered the really delicious stuffed pomfret, which is amazing if you ever get to try it. But it's a fish and they don't always have it in stock, right? And so if you're just out of that, you've sold them all and you have no more, it doesn't matter how many times you try to recook that order, the result is going to be the same. No pomfret, no pomfret, no pomfret. So if the nature of this exception is such that if we try again, it will never succeed. If it's just never going to succeed at this point, let's just go ahead and dead letter it at that point, just give up. So that's a way in which you might leverage abandon versus dead letter to help the business logic of your application. Another thought is sometimes the problem with a message is like a platform issue. So let's say that the reason the parota burned, the problem we ran into is that, I'll give you a real world example. I worked on an app where we needed to make some API calls to a third-party REST API. And sometimes there would be service interruptions. And so we would get token errors or TCP transport errors, where basically we had tried to talk to it and we couldn't. So in this case, we know that this message will succeed. We want to retry, but we don't want to try again right away and burn through our retries. So what we would do is we would set a backoff flag, basically saying, okay, that resource is offline for a while. We're going to set a flag, however you do it, in a SQL database or something that says anybody processing these queues, just hold off. No more processing for now. And then we would start a watchdog that could test the service. And it would test every minute or every 2 minutes, be like, well, did it come back online? Nope, keep waiting. And eventually, if it came back online, we could say, all right, all clear, blow the whistle, and let everyone back in the pool. And then all the queue processors can go again. So that way, we're not DDoSing the poor service that's trying to start, right? There it is, having a service interruption, and we're just hammering it with our requests. So we back off to give it a chance, and also we're not burning through our retries and having all these messages pile into the dead letter queue, and then we have to replay them all or do something. So that would be a nice way that you could abandon, but then also pause and prevent future processing based on some condition. Now, of course, all of this is based on your business logic and your app. My point here is just to give you some food for thought on how these alternative kind of resolutions of a message might come into play. All right. In the next video, we're going to start having real fun. We're going to start talking about receiving multiple messages in a batch.